Hello students, today we will be seeing sets exercise. Disclaimer, the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is an experimental. So starting with this question, make correct statements while filling in the symbols of subset and not subset in the blanks. So we are having 7 statements. First one, so we are having 2 sets in roster form. First one is with 3 elements 2, 3, 4. Second one is with 5 elements 1, 2, 3, 4, 5. In second, we are given with 2 sets in roster form, both containing 3 elements. So first one is ABC and second one is BCD. Third, 2 sets described in set builder form. First one is collection of all X, and the collection is of your students of class 11th of your school. And second set is collection of all X, such that X is your student of your school. In fourth, set builder forms are given to you. Collection of all X such that X is a circle in the plane. And second is X such that X is a circle in the same plane with radius 1. So unit circle. Now fifth statement with 2 sets in set builder form. First one is collection of X such that X is your triangle in a plane. And second is collection of X is your rectangle in the plane. Sixth, collection of X such that X is an equilateral triangle in a plane. And second, collection of X such that X is a triangle in the same plane. Seventh is collection of X such that X is an even natural number. Second one is collection of X such that X is your integer number. I hope all sets are clear to you. Now you just have to accordingly fill these 2 symbols. Simple. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. Let's move on to the solution slide. So we are given with 7 statements and each of them we are given with 2 pairs, not 2, just pairs of sets, and we have to insert these set, subset and not subset symbols. Solution. So for first, in order to be a subset, what we require is simply every element from this set must be belongs to this set. So just observe, 2 belongs to both set, yes. 3 also belongs to both set. 4 also belongs to both sets. Meaning, by definition, the set with elements 2, 3, 4 is indeed a subset of the set 1, 2, 3, 4, 5. Now for second, set with elements ABC is not a subset of the set with element BCD. Why? Because in order to be not a subset, we just required at least an element from this set which does not belongs to this right hand side set. So you can easily name that element, which is A. So A belongs to the set while A doesn't belongs to the set in RHS. Clear? So not a subset. Now for third, collection of all X such that X is a student of class 11 of your school, which is indeed a subset of the set where you are having your collection of your students of your school. Simple. So student or collection, or from this set, if you pick any student, that student also going to be a member of this set. Clear? So by definition, we are going to use or fill the symbol for subset. Now for fourth, this set represents collection of all circles in the plane, which is not a subset of collection of all circle with radius 1. Why? Because in this set we also have circle with radius 2, with radius 3, and that element circle with radius 2 doesn't belongs to the set here. So we used not subset symbol. Clear? Now for fifth, collection of X such that X is your triangle is not a subset of the collection of all X such that X is your rectangle in a plane. So why? Very simple, straightforward. Here we are collecting triangles, while here we are collecting rectangles. So triangle or element from this set not going to belongs to this set. Why? Because a triangle is triangle, not a rectangle. Simple. Now for sixth, collection of X such that X is an equilateral triangle in a plane is a subset of the collection of X such that X is your triangle in the same plane. So if you observe that elements from this set, which is equilateral triangles, also be a member from this set. Why? Because here we are collecting all triangles: equilateral, isosceles, scalene triangle, right angle triangles, all triangles. So every triangle from this set must be in this set by just the formation of our sets. So subset. Now for seventh, collection of X such that X is your even natural number, which is indeed a subset for set collection of X such that X is your integer. Why? Because every natural number is your integer. Clear? I hope it is clear to you. Now this question. Examine whether the following statements are true or false. For first, we are given with this set in roster form A comma B, which is not a subset of the set in roster form BCA. And second, it is given that set with elements AE is a subset of the set described in set builder form, collection of X such that X is a vowel in English alphabet. Third, set in roster form with element 1, 2, 3 is a subset of set in roster form with element 1, 3, 5. Fourth, this singleton set with element A is a subset of the set with element 3, ABC. And fifth, this curly brackets A, this singleton set belongs to the set in roster form with elements A, B, C. And sixth, this set described in set builder form collection of X such that X is your even natural number less than 6 is a subset of the set described in set builder form collection of X such that X is a natural number which divides 36. Clear? So you just have to answer true or false. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. Moving on to the solution slide. So 6 statements are given to us and we just have to state true or false solution. So first one is false. Why? Because if you observe the set with 2 elements A, B, we can easily see that both these elements belongs to the set with the element B, C, A. Yes? So by the definition of subset, it is a subset. While in a statement it is given, it is not a subset. So false. Now second one is true. Why? So from the definition, it is easy to verify that all the elements from this set, in this case AE, belongs to the set described here. So if you write the roster form for this, you will get A, E, I, O, U, meaning A and E will be there. So true. Simple. Now for third statement is false, meaning it is not a subset while it is given to a subset. Because 2 belongs to the set with element 1, 2, 3 while it doesn't belongs to the set with element 1, 3, 5. So by definition, it cannot be a subset. So false statement. Now for fourth statement is true. Why? Because this is your singleton set and that we are having element A. And A element is belongs to this set. Yes, so by definition, it is a subset. So true. Fifth one is false because we used belongs to symbol and we, if you recall, belongs to symbol only used when we are describing that this is your element from this set. Meaning we are saying this here we are treating this as our element. This as our element. So if you try to see curly bracket A, this statement is saying curly bracket A, this belongs to the set ABC while it is not. A belongs to the set ABC, but curly bracket A doesn't belongs to the set ABC. Clear? It is subset, not belongs to. So false. Now for sixth, it is true because if you write the roster form or simply we are collecting here even natural number less than 6. So you can easily write the roster form which is just 2, 4. And for second collection of natural numbers, divide 36 simply 1, 2, 3, 4, 6, 9, 12, 18, 36. So you can easily observe that 2 and 4 both belongs to this set. So by definition, it must be subset. So true statement. I hope it is clear how we got our answers. This question. Here set A is given to us with element 1, 2, curly bracket 3, 4, 5. So this represents an element of set A, this whole. Now, as you can see 11 11 statements are given to us, and we have to answer that which of the following are correct and incorrect, and also give our explanation. So first says the set 3, 4 is a subset of A. Second says this set 3, 4 belongs to or element of A. Third say the set which is set 3, 4 contained in A. Fourth say 1 belongs to A. Fifth say 1 is a subset of A. Sixth say 1 to 5 set is a subset of A. Seventh say the set 1 to 5 belongs to A. Eighth says set 1 to 3 subset of A. Ninth says 5 belongs to A. 10th says 5 is subset of A. And 11th says set containing 5 is a subset of A. Quite interesting question. So you will have some seconds to try this problem. Then afterwards we will move on to the solution slide. So your time starts now. The time is up. So set A is given to us and 11 statements are also given to us. We just have to state correct or incorrect with reason. Solution. Given set A in roster form with elements 1, 2, set 3, 4 and 5. First is incorrect because this set, first statement is saying this set with element 3, 4 is a subset of A, while it is not. Because in order to be a subset, we require 3 and 4 both belongs to set A. As we can see, 3 doesn't belongs to set A. Clear? Now for second. It is correct because this is here we are treating this set as our element of set A. So indeed, as you can see, we are having 4 elements, 1, 2, this set and 5. These 4 elements of A. So correct. Now third, which is also correct because this subset treating as 3, 4 set as element, and we know this element belongs to the set A. So by definition, it is a subset of A. So correct. Clear? Now for fourth, 1 belongs to A. Yes, 1 belongs to A. So this statement is also correct. For next part. Fifth, 1 contained in A, incorrect, because 1 belongs to A is not contained in A, not subset. Simple. An element of a set can never be a subset of itself. Simple. Now for sixth, set with element 1 to 5 is indeed a subset of A because all elements 1 to 5 from this set belongs to set A. As you can see, 1 to 5. For seventh, set 1 to 5 belongs to A. No, incorrect, because it is a subset, not treated as an element. Clear? So incorrect statement. For eighth, this set 1, 2, 3 is a subset of A. Incorrect. Why? Because 3 belongs to this set while 3 doesn't belongs to set A. As you can see, in set A we are having 1, 2, 5 and this complete set belongs to the set A. So we are having only 4 elements in set A. 3 single elements and 4th, as you can see, a set. Now for next part. 9th, 5 belongs to A. As you can see, we are not having 5 as our element. So 5 not belongs to A. So incorrect. While in theory, we saw phi is a subset of every element. So this statement is going to be correct. So correct statement. Now for 11th, this set contain in A incorrect, because in order to be a subset, this element must be in A, while it is not. So phi doesn't belongs to A. So incorrect statement. I hope all these reasons are clear to you. Now this question. So here we have to write all these subsets of the following sets. So in first, singleton set. In second, sets with elements A, B. In third, sets with element 1, 2, 3. And in fourth, empty set. You'll have some seconds to try this problem. Then afterwards, we will move on to the solution slide. So your time starts now. The time is up. So in question, just write down all the subsets of the following sets. Solution. So for first, this is our singleton set, and we know phi is going to be subset for every set. So phi and the set itself. So we are having two subsets. Now for second, with two elements, phi will be there. Singleton sets will be also there, and the set itself. So four subsets. For 3, phi 1, 2, 3 singleton. Now pairing with two elements, so 1, 2, 2, 3, 1, 3, and the set itself. So total 8 subsets. Now for empty, we are only going to have one subset, which is the set phi itself. Observe here, the number of subsets of a given set is simply given by 2 raised to the power number of element in that set. So here we are having one element, so 2 raised to power 1 is 2. So as you can see, 2 subsets. 2 elements meaning 2 raised to power 2 is 4. So you can also verify 2 raised to power 4 is 4. So 4 subsets. 4 subsets indeed. Now 3 elements meaning we will have 2 raised to power 3 number of subsets. So 2 raised to power 3 is 8. So if you count, you will get the correct or the same number. So we are having 8 subset for this. So it is generally true. Clear? Now here we have to write the following in terms of intervals. So first one is collection of x such that x from real numbers and x is greater than -4 but less than equals to 6. Second, collection of x belongs to reals, x is strictly greater than -12 but strictly less than -10. Third, collection of x such that x belongs to reals with x greater than equals to 0 less than 7. And in fourth, collection of x such that x belongs to reals and x greater than equals to 3 less than equals to 4. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So very simple, just write the intervals for 1, 2, 3, 4, these 4 parts. Solution. So for first one, as x belongs to set of reals and reals coming from greater than -4 less than equals to 4. So we are having strict inequality at -4. So we are using open bracket at -4 and closed bracket at 6 because we are having this inequality with equality less than equals to. So whenever you see less than equals to or greater than equals to, you use your square bracket. And if you are having strict inequality, then you use your round open bracket. So this round bracket suggests what? We are excluding the number, and closed suggests what? We are including the number. Now for second, all real numbers. greater than minus 12, less than minus 10. So open interval minus 12 to minus 10. For third, all real number greater than equals to 0, less than 7. So we are including 0, excluding 7. So closed at 0, open at 7. Fourth, collection of all reals greater than equals to 3, less than equals to 4. So we are including both 3 and 4. So we are going to use square bracket. So square bracket 3, 4 represent the closed interval 3, 4. Clear this question? Now we have to write the following intervals in set builder form. So first one is open interval minus 3 to 0. Second one is closed interval 6 to 12. Third is interval open at 6, closed at 12. Fourth is interval closed at minus 23, open at 5. You'll have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So we just have to write the set builder form. Solution. For this open interval minus 3 to 0, we are collecting all real numbers. So collection of all x belongs to reals, and we are excluding minus 3 and 0. So we are collecting in between numbers only. So we are going to use strict inequality. So x strictly greater than minus 3 and strictly less than 0. For second, we are including both 6 and 12. So we are going to use greater than equals to or less than equals to symbol. So collection of all x belongs to real such that x is greater than equals to 6, less than equals to 12. Now in third, we are excluding 6 but including 12. So we are going to use a strict inequality for 6 while we are using less than equals for 12. So collection of all real numbers with x strictly greater than 6, less than equals to 12. And in fourth, we are including minus 23 while excluding 5. So we are going to write the set builder form as collection of x such that x belongs to reals and x is greater than equals to minus 23 but strictly less than 5. Clear? Now this question, we have to describe the universal set. So for first, the set of right triangles, and for second, set of isosceles triangles. So you will have some seconds to try this problem, then afterwards we will move on to the solution slide. So your time starts now. The time is up. So here we just have to describe our universal set. Context already given to us. In first, we are considering right angle triangle. In second, we are considering isosceles triangles. So solution. So for first, you can take your universal set as set of triangles. And in second, you can also take your set of triangles. Yes? Clear? Now this question. Sets are given to us. A set with 3 elements 1, 3, 5. B set with 3 elements 2, 4, 6. And C set with 5 elements 0, 2, 4, 6, 8. And which of the following may be considered as universal set for all the 3 sets A, B, C. So 4 options are given to us. First one is with elements 0, 1, 2, 3, 4, 5, 6. Second is 5. Third is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And fourth is 1, 2, 3, 4, 5, 6, 7, 8. You'll have some seconds to try this problem. Then afterwards we will move on to the solution slide. So your time starts now. The time is up. So in question, we just have to describe our universal set, or just choose. We have to choose the universal set. Solution. So first, this cannot be universal set because in order to be a universal set, all these 3 sets described in the question must be subset of that universal set. So C, not a subset for the first option. Why? Because 8 does not belongs to this set. So this cannot be described as a universal set. Now for second, 5. So we can easily observe that A is not a subset of 5, and the same goes for the remaining two sets. So by simple definition, it is not a candidate for universal set. So cannot be taken as a universal set. For third, A is a subset of the given set, B also a subset of given set, and C also a subset of given set. So all these three are subset of the given set, or in another words, this set is your superset for these three subsets. So if you are having such case, then you can immediately answer that you have found a universal set. So this will be your universal set. Now for fourth, we can easily see that C not a subset of the given set with element 1, 2, 3, 4, 5, 6, 7, 8. Why? Because 0 doesn't belongs to the set, while 0 belongs to C. So cannot be a universal set. So we have found our answer. The universal set is in option C. Clear? So this is it from this session. Thank you.